It's you, and your audio is on, and I can hear you great.
Yeah. Happy Monday.
Okay, is that how we're going to do this now?
Sure.
What is even a day? It's just an abstract construct,
I
much less
was
a week.
I said that to someone the other day. They asked me about my plans for a specific day, the weekend. And I said all of these days are the same. I work, I see people that I want to see, and I'm busy. I
My
have
weekends are a lot different due to the 5-day nature of public school in America.
mm, do you try
So
to
my week,
do do you try to do family tasks?
no, I'd try and do family fun, but not family tasks. I got stung by a yellow jacket on Saturday on my finger, and it still hurts. We were at the fall festival in the neighborhood. I had on a hat. I stuck my hand up in my hat, and I felt a sharp, well, it felt like a pinch, but it was not a pinch. It was a sting. And then I mean, I didn't even see the yellow jacket, and now it's been 48 hours. It's still, I mean, it doesn't hurt a lot, but I can still feel where I was stung. And I'm like, I just hope that yellow jacket is happy, but I don't think it is happy because I think yellow jackets and most animals of its stature are basically just like some neurons firing. They don't really feel a sense of happiness whether they sting you or not.
Yeah.
But do you want me to seg? Because I can seg straight.
Let's go. This will be a work of art.
No, it's easy. We
All right.
ascribe we ascribe personalities to the things around us. We can't stop. A bee may not even may have no sense of happy or sad or anything else. We don't know, but we just personify the bee. The 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 places we spend time. We put human traits on them. The machines that we build to do our bidding. We cannot stop personifying those things. The idea of a humanoid robot, man, I've got a lot to say about this. The idea of a humanoid robot to me is well, okay, there's a couple ways of looking at it. One, it's a huge distraction, meaning the point of a robot is a mechanical device to save labor or increase efficiency or reduce risk or something like that. But the idea that we're going to be making a copy of ourselves completely disregards the actual, like, mechanization versus robotics, right? Robotics is a subset of mechanization. Not all mechanization is robotics. But why not? The thing that makes robotics robotics is that we put, smiley faces on them and give them arms and legs and then personify these objects. Nobody personifies the autonomous dump truck that works in a mine. I mean, they do, but not to the degree that we do with robots. So that's my segue. We personify everything. We shove human traits onto animate and inanimate objects alike.
Agreed. Did you read the name of the hot dog dispensing robot
Yeah, what was it?
that was in the IEE?
That's not Weenie Mate, is it? Is it really
Speedy Weenie.
Speedy Weenie? So this is the fascinating thing. I think if you're a roboticist, it would really bother you, or an inventor who works in robots and things related to robots. I think it would really, and I don't know this for sure because I'm not them, but I think it would really bug you to be told that your life's work in mechanical device building and programming is somehow, it's about marketing and product packaging more than it is about, can I manipulate this object with a arm that is hydraulically actuated versus electrically actuated versus whatever else. Like, if you like, designers of robots by and large are thinking in terms of specs, and to a lesser degree they're also thinking in terms of, problem to solve or thing to be automated away with a machine. And I think the piece of this that is, I'm not going to say it's a fresh idea. I'll say it's an idea that is not talked about a lot. Is the productization of those mechanical things is part and parcel with what makes it a robot. Because otherwise, we're just talking about mechanized automation, and you don't have any robots industry or robotics industry or roboticists or any of this stuff without the without the imagination piece of picturing these things doing work for us.
They're the interesting. I really wanted to get, or we will want to get into the history of at least industrial robots. And I think what you're explaining is an interesting story about, and I forget the plant. It's in Ohio, um, Lordstown or something like that. I've got it here. Originally, the first robot, and we'll talk about this history, but the first, I believe, Unimate was the brand, and George Devil was the designer, the patent holder, from Louisville, Kentucky, I might add. The original application of his robotic arm was in an application. The commercial application was in a GM plant, the first one in Trenton, New Jersey, the second in a plant in Ohio. And originally, one of the articles that I read talked about this. Originally, there was little resistance from the human workers, from the human capital, to this robot arm, because the job that it was doing was the hottest, nastiest, most dangerous. It was removing, I think, cast parts from something heated.
Yeah, it's like heavy foundry work.
Foundry work, yeah, great application for a robot, and it was met with little resistance. But then GM started to see the benefit in automating with this robot several of their processes, and they started applying it to spot welding applications and other applications, and it led to a full shutdown of this plant for, I think, 22 days. And that was sort of the first shot across the bow in opposition of this technology potentially replacing human jobs, workers' jobs. And after that strike and all of the kerfuffle surrounding the strike, it was sort of anathema to be associated with this robot, or it didn't gain widespread adoption here until it picked up in Japan, and then was a huge part of the Japanese. I think it was a JV between Kawasaki and Unimate, or Unimate licensed the technology to Kawasaki. Japan used it, automated many processes with it, obviously, and then the rest is history. But I think what you're explaining is an interesting side story or subplot of things today, parallels of things today with the origins of robots and robotic arms.
Yeah, the subplot is carried through all things robot and the whole history of robots. I think it's a history where, we've had a century of robots as we know them, and I'll cite the definitions that you found. These are compiled by the Stanford Computer Science Department. There's a couple different. The dictionary definition is okay: an automatic device that performs functions normally ascribed to humans, or a machine in the form of a human. Pretty broad, but also accurate. The RIA, the Robot Institute of America, which is still sort of like a preeminent trade body representing robotics manufacturers and integrators. Their 1979 definition is a reprogrammable, multifunctional manipulator designed to move material, parts, tools, or specialized devices through various program motions for the performance of a variety of tasks. Now, so from the dictionary definition, which also includes a machine in the form of a human, to the Robot Institute of America. I mean, sure, it's the Robot Institute representing all definitions of robot, but once you get into this is a manipulator designed to move things, or be programmed in a particular way for the performance of a task. Okay, now you've narrowed it down from this is Rosie the helpful house robot to this is clearly the industrial domain that we're talking about. So this is like it does factory tasks of some kind. And I think that distinction is important, because robots, as they get sold and used per these definitions, look like industrial robots, sometimes autonomous guided vehicles, but mostly they look like industrial robots and self-driving I won't say cars, it's not fully a robot, but self-driving submarines or remote operated submarines or self-driving, AGVs for material handling in a warehouse environment or something like that. So there's only a couple of classifications of what we're used to when we're imagining robot, but then the the actual the automation definition of this, of anything that manipulates a thing to do a task, all of that's a robot per the RA definition. I mean, I think that's intentionally broad, but that covers everything from a machine that fits in a small footprint and moves from place to place with arm like things and hand like things, and it also covers just a conveyor belt that has a pusher thing on it that pushes it into a bin that is then wheeled away on a cart by a person. And taking an ultra broad definition of robots like that is really unhelpful when talking about industrial automation. So I almost don't talk about robots in the industrial automation space. I talk about automation, a subset of which is robotics. And if you want to talk about which of those is most interesting to me, like if we're having a dinner party conversation, I'll say robotics. But if you have any idea what a robot is, I'll talk about industrial automation, and I won't even say robots because, like, the civilian definition versus the I'm doing something with this definition as opposed to imagining the future, it's a huge gulf, and it's important to be able to get those things straight. And one of those exists mostly in imagination. The other exists mostly in real life places where robots do stuff.
Yeah. You know who originally coined the term robotics? You read
Yeah,
the
my whole argument kind of hinges on where the term robot and robotics both came from.
Isaac Asimov, 1941.
He coined robotics
Yeah,
in 41.
yeah. Interesting though that the we talked a little bit. I guess I don't remember when. One of our first episodes, we talked about STEM and STEAM,
Mm-hmm.
and I think that's an interesting example. Um, anyway, so
Well,
what?
hold on. You gotta finish your timeline here. So Isaac Asimov stemmed the term or coined the term robotics, but it's a derivation of robot, which was coined 20 years earlier.
Yeah, who coined the term 20 years earlier?
Carol Chapek, who was a playwright. So the
That
original
yeah,
the original occurrence of robots is Rossum's Universal Robots, which is the title of a play. So you have a creative, an artist, a writer, playwright who has invented this notion of a robot. Isaac Asimov, arguably the most well-known and universally read science fiction author of all time, but still science fiction author, not a scientist or a roboticist per se. He derives the term robotics from robot, and it's like, okay, so all of this stuff is coming from the creatives, which isn't bad. It's just, think about that as a perspective and how it would be different if it was all coming from people who physically invented the machines as opposed to talked about the idea of the machines.
so that was my point on the whole STEM and STEAM discussion is
Yeah.
the fuzzy parallels and overlaps between uh, creatives, regardless if you're creating art, if you're a writer, or you're creating new physical concepts scientifically. Those lines are fuzzy a lot, and I think that's interesting here. I'm fascinated by George Duvall's story, though. I didn't know him. I didn't until we started reading through some of this material. I didn't know him. I didn't know he was from here. I didn't know his story. I didn't know that the spot welding robot. See, I have a history with spot welding robots,
Yeah.
and I think you know a little bit of it.
We have a very narrowly shared history with spot welding robots. Just
That's correct.
a brief tangential relationship
Well,
there.
you know, it's interesting. Spot welding robots are how you and I met.
Right. Yeah.
That's why I called the Standard Spotty that you were the managing director for.
Right.
Anyway, they the gentleman who invented that arm, the patent and sort of the technology was called Unimate. I believe was the original arm,
Unimate's the
robotic
first
arm.
robotic arm. Yep.
Yeah, the gentleman who invented that was born in Louisville, not a degreed engineer. not a scientist. One of those special sort of, I mean, really, this guy should be talked about. Maybe not Tesla, Nikola Tesla, but he should be talked about in those same conversations. He patented a ton of things, wasn't a degreed engineer, very unique individual. And I think a lot of the successes of industrial automation can be traced back to him and his robotic arm. Anyway, his story is very interesting. There are articles on him if anyone wants to dive into that. I think one other aspect that I'd like to bring up in parallel with that, so he really didn't have commercial success with the arm until he met a partner, and here comes sales and marketing. I don't remember the gentleman's first name, but Engelberger was his last name, and the guy was a marketing genius. He had the first Unimate, or one of the early Unimate versions, on the Tonight Show with Johnny Carson, and had it open a can of beer. And when I was reading that, all I could think about was the parallels with AI today, and all of the different tangents or tentacles of the narrative, the story, the science, obviously different technologies. There is an overlap there too, but the all of the concerns and the sort of stage we are with AI, the parallels with robotics. And I think the key for that, that anecdote of the first arm opening a beer can on the Tonight Show with Johnny Carson, the thing that I take away from that is we see the same types of things, sort of the gimmicky hat tricks of what AI can do today. There were concerns then about the robotic arms or robots taking, automating people out of work and taking over the world. I think that's yet to materialize and ever will. And I think those it's interesting watching the AI discussion parallel or mirror to some degree the original timeline and trajectory of this robotic arm. This whole story is fascinating to me.
It can be hard to accept that you are currently living in history.
Mm.
That can be hard to grasp. So it's not like there was this story of the commercialization of the Unimate robot, previously called the article transfer device or some nonsense machine name. It's not a story that happened then and now we're in a different story. It's
Right.
the same story. Like the mass production of article transfer machines and the pivot from most of the value of a robotic arm being in metal and mechanics, to now it's largely the value is in software, or at least the untapped value is in software. All of that is just a continuation of exactly the same story, and you can kind of pick virtually whatever beginning point you want, right? So you can pick this was the first Unimate, or you can tell the story of, well, 10 years before Unimate, you had George Devol invented the thing but couldn't sell it, and that's a story. And then you have, what did OpenAI look like before they had a couple of choice investors? What did large language models look like before they had the bundling and packaging and a front end to it and it got called Chat GPT and then Fast Follow or Bard, right? Like, what did all this stuff look like? And even if you just stick with the extremely narrow robotic arm versus, AI 2023, that's the same story, but it's also the same story if you do, autonomous guided vehicles, which is basically another category of robot. It's the same thing if you talk about self-driving cars. It's the same thing if you talk about, avionics and drones. There's the same story of automation, mechanization, softwareization. It plays out over and over and over and over and over again in ways that are, and this, I think it's important to respect the duality here. There are things that are identical between these stories, and then there are also things that are completely different, right? So the universal reach of everybody who has $20 and an internet connection in their house can speak to an AI and ask it to add a reminder to a list. An example of this, right? So I'm reading a book for elementary school kids with my elementary schooler. There's a part when the middle school character, who is the hero of the book, he's preparing for a test, and he doesn't think there's any reason to bother with memorizing the world's largest river delta. No, the world's largest estuary. Like this was this was his quiz question was, what's the world's largest estuary? And the kid is like, I don't see why I need to learn this, because there's going to be a robot in the future that can tell me what the world's largest estuary is. Now, the best part about this is not that this book, which was written in 2009, by the way, correctly predicting that you could ask something in your house what the world's largest estuary is. So shout out to Diary of a Wimpy Kid for correctly predicting estuary bot. Now, the best part is what it got wrong. The picture illustrating the main character, Greg, asking a robot what the world's largest estuary is, has this big boxy humanoid robot on tracks. So it's like it is impossible to avoid the personification of the thing that isn't a person, right? Like
Yeah.
the little light up doodad on the wall that's just a speaker. All of the personification of whichever home assistant of your choice or the ones built into your phone, those things are, all of their humanization comes from how they speak, human like, and the fact that they are, a human sounding, natural sounding voice. That's the only thing that makes them human like.
But the interesting part of that, and this is very much the sausage making that no one wants to entertain,
Yeah.
is
Yeah,
that
exactly.
it is the crux of the thing. Is the interesting part of that is 5% of the technology that we are scared of. If we understood the technology, we wouldn't be scared of it, because it doesn't work that way. It's not a human just because it's
Right.
it's speaking back to you in a voice that sounds like it might be your neighbor's, or a mechanized version of your neighbor's voice. The thing making that go is only that the thing that people hear talking, that robot that people hear talking, would only be there if not, the only reason it's there is the ingenuity and the intelligence of the human who built it.
And the
That's
design,
and
it is specifically and explicitly designed.
so the fact that you hear words coming out of Alexa or Siri or ChatGPT, or pick your medium, the fact that you hear words coming out, you have to understand that thing that's putting words back to, or projecting words back to you, has no idea what it's doing. It is a
That's, that's right.
it is a mathematical algorithm that is predicting the next thing it should say.
I'll take
It
you one farther. It doesn't have ideas.
no
Forget about any
ideas.
idea what it's doing. It's less into, yeah. Here's a, you're not a video game guy, right?
I'm not. No.
Uh,
Does this surprise you?
no. When you said the Amazon Home Assistant and the Apple, whatever you call the voice assistant for Apple,
Siri.
I can't say their names out loud because each one will cause a thing to come on and start, trying to hear my instructions. Anyway, there was a competitor from Microsoft named Cortana. Are you familiar with
I
this?
am.
And Cortana was the AI, meaning a human form AI with a little like hologram character to it, in Microsoft's first ever big name video game release when they created the Xbox in 2001. Microsoft hadn't really been in video games. They made computers, they made software, but they didn't really make video games. It was a kind of a big gamble that they were going to roll out the Xbox console. It was a little bit expensive and a little bit more powerful than everything else. There was some significant debate as to whether this thing was going to catch on or not. The thing that caused this sort of really get big was it had this one game that was only available exclusively on Xbox. That was Halo, which became, this ultra mega blockbuster video game phenomenon. And the AI in 2001 in that game was named Cortana, which then Microsoft baked into Windows years later as a, like, not, it wasn't a nod to, it was a literal pick up and put down. Hey, if you know Halo, you know Cortana, and that's the AI. And now we put that into your Dell PowerBook PC or whatever it
And
is.
they've moved on from that as
Yeah,
well.
it was a disaster. Like, it
Yeah.
did not work at all. Like,
So
people were not picking that up.
gaming, and I'm asking this for a reason. Gaming, do you know scale relatively popularity of games, gaming, and Apple's products? Like, what's the relative scale? Or and not just Microsoft's version. I guess PlayStation is another version
Good
made by
pull. Good job.
Sony.
You nailed it. You crushed it.
Yeah, made by Sony.
Great work.
There are others, I'm sure, but do we know scale wise what the size of the gaming market is compared to Apple?
So
Market cap would be fine. Anything even close?
something like 55% of adults from the ages of, I don't know, maybe 16 to 65 or something like that, play video games in one capacity or another. Now, this is a broad reading, right? So that includes sit down in front of my TV with a console in my hand, or it includes I have my phone and I'm sitting on a train and I'm popping bubbles in an app. But you know about half of adults play video games in some capacity. As far as like the size, I think it's video games are about the same size as TV. Like television and video games are roughly the same size market. I don't know how that compares to mobile apps as a market.
Because I think there's a pretty pervasive and widely held belief, at least in circles, that Steve Jobs is the master marketer and convincing people to buy devices that they didn't had no before the iPhone.
Yeah.
There was no, how are you early? How do you how do you project sales of that technology without saying we're creating our own market?
Yeah.
And I think he's widely regarded, rightfully so, as genius in that respect. I see it as whoever is doing that from a gaming perspective. Now, obviously, there's a lengthy history of games and our relationship to them. But in terms of devices or software, things that people spend a lot of money on to play games, I think that demand creation is equally impressive in my book. Unless it's I'm missing something that's it's a ready-made addressable market that all you have to do is develop the right things. I don't know that space, so I find it
It's much
impressive.
more evolutionary. So you think about there was an iPhone moment. There was no iPhone, then there was iPhone. I talked about the Xbox being this watershed moment. It's nothing in comparison to the iPhone. Both number of reach and the amount of stuff that came after it, and lack of proximity to its neighbors, number of copycats. I mean, the idea that you would have a full screen device in your pocket connected to the internet that also plays music, that's also your phone, like that. The next closest thing that it was replacing was a BlackBerry, which was not
Yeah,
not that. And BlackBerry was huge, but it had a very niche audience, right? It was every single person who flew around the country on an airplane and was very busy and important. They all had BlackBerries, but that was compared to the market for all people who will have a cell phone, minuscule.
yeah, yeah. The scale is probably much smaller compared to Apple, but I think that demand generation, I'm always impressed with that and the risk associated with that, and just the is it's not blind egotism, or I don't know what it is, but whatever it is that makes an individual believe, yes, there's zero prior art for this thing that I'm spending my
Yeah.
entire life on, but I am convinced that this thing's going to work. That's akin to, in my book, the Nina, the Pinta, the Santa Maria, dropping a wooden boat in the ocean and sailing into the unknown. The respect that I have for that is exceptional.
I think if you were to spend some time digging into the industry as an industry, the gaming industry, you would be disillusioned quickly and come out disgusted more than
No,
more than impressed.
I would not be disillusioned because my bar is already very low for the
I
gaming
when I
industry.
so when I think about being raised with opinions of industries, I would say that one of the most formative recurring stories of my professional career is the excitement around getting involved in robots. So, if I was doing factory automation work when I was in my early 20s, that factory automation work, some of it was robots, some of it was lasers cutting metal, some of it was, CNC machining, which is not particularly well understood by the average person. So my shorthand was, I'm working on robots and lasers now. And like, that's a huge segment. You can do a lot of different things. I wasn't building robots and lasers, I wasn't using robots and lasers, but my work concerned robots and lasers directly. And that was able to communicate to anybody that had seen a James Bond movie where James Bond's going to get cut in half by a laser, or anybody who has seen any movie where a robot is, or like robots as robot arm is a known entity, right? So that by itself was interesting. But then the contrast where you started to realize that, I'll just stick with robotic arms, right? None of the rest of this stuff. The robotic arm industry has been repeating the same things and the same technology and the same approaches and the same business models pretty consistently for a long time. So, this was probably the late 2000s when I got involved in this stuff, and it was, so we had really 2, maybe 3 decades of precedent of kind of it's not that it was stagnant or stale or anything like that, but it was very conservative in the sense that change was risky. If your robot messes up, people can die. Therefore, there's a propensity not to want to change things. Um, so it was like realizing that the novel, cutting edge, really building it mechanical, electromechanical programming stuff was not necessarily all new technology in the same way that certainly an iPhone was. That contrast of, all of this stuff is old, but it's in this industry that is, like, it's these topics that are supposed to be cool and amazing and stuff like that. And then things kind of flipped on their heads, because starting in the 2010s, the robotics industry got like a couple ejections of, new ideas and new companies, and things started to change again. And consumer grade 3D printing had a huge impact on it, because that was people that got used to how they make stuff with machines, and that brought a bunch of new people into the industry. So anyway, I think my point I was trying to make is that contrast between, this is all the stuff that's lasers and robots. How is it possible that it's also such an uncool place to be to be working? And that was a fundamental awakening, or like realization. This thing that I thought, coming into it as the outsider, getting the story version of it, it must be interesting in these ways, and then finding out, well, it actually is interesting, but it's in about 20 other ways than you thought, and none of the ways that you thought it was cool before you came into it.
So clearly, we've arrived at the same spot, starting from different points. Obviously, I did not grow up around robots. And I can't, I'm always careful not to make value, and I say this a lot because it's important, not make value judgments, just objective assessments. I don't know why, but I hold in probably the highest regard. I recognize the importance of software, but in terms of industry and industrial applications, I have a soft spot for power generation. It's another conversation, but robotics and industrial robots and the importance to manufacturing, productivity and efficiencies, and just the industry of automation generally, I have such a high regard for. And probably an outsized with respect to importance, at least here, or declining importance. Hopefully, that has waned, and manufacturing is, resuming its 80s level importance. But I have such a unique appreciation and view of robots, industrial automation, the synergies between all of those things. I'm fascinated by it.
Well, the George Devol story really helped, because reading the stuff that he invented over time, he was not really a roboticist. You
At,
know,
at all, at all,
if you
yeah.
think about what we could consider roboticists starting from the 80s, that's someone who has some industrial
A mechanical,
electronics
probably.
engineer. Yeah, you got to have some mechanical skills, some electrical engineering skills, some programming skills, and that's the bulk of it. And if you have that cross section of skills, that's what's required to be a roboticist, which means that you can build, install, control, or maintain a robot, or delegate that work to people based on your knowledge of the system overall. So that's a roboticist, but the inventor of the robot as we know it, he was a generalist inventor, primarily mechanical. He also lived at the intersection, like right at the end of the tube era and the beginning of the solid state era. So his electrical stuff was very much in the how do we get away from tubes? What can we do with transistors now? But you could tell from the list of things that he worked on that what he was interested in was solving meaningful applications with electromechanical devices, right? And that's not necessarily what a roboticist by training is doing now all the time, right? So they're kind of handed something and it's a robot and their domain is going to be a robot. And that's not exactly the same as I have an open-ended fix to, maybe the fix is a robot, maybe the fix is a washing machine, maybe the fix is a microwave, maybe the fix is an automated door, right? So the same guy who invented the robots, George DeVol, he also invented and patented an automatic opening door,
He did
right?
that.
Right? Which is it a robot? Not by the has a face and hands and is going to replace us definition, but by the does a task automatically definition. Heck yeah, it's a robot. So I love that he was coming at it from a don't the discipline isn't robotics. The discipline is applied
Problem
problem
solving.
solving. Yeah.
Correct. Yeah. Same thing with AI. And this is I'm
What,
having
what is an AIist? What is the roboticist equivalent of an AI practitioner?
a computer science. Actually,
Data science, data scientist. That's not even enough.
data scientist.
That's still not enough because there's data scientists that do stuff that's not AI.
For sure.
Yeah.
And that's the vast majority, actually. Again, I think they're the same people. They're the same people with different tools in the tool belt.
We need the ghost of Isaac Asimov to come up with a term now. We've got AI, but now we need the the AI assist.
Digital
The term for that to be invented.
digitalist.
No, that would never work. That's way too broad. Because even data scientist isn't going to cut it.
Yeah.
I think it used to be. I mean, 3 years ago it was AI researcher. That was the term.
I made this statement. I've been fortunate recently to meet some very interesting people in all sort of positions in the applied AI space and the AI space. And I was explaining that I think the next $1 billion company or the next really big company in applied AI is that it's a solutions provider. And think of it as I'll leave it at that. I think that they're, again, we talked about this, but I think the number of tools and storage architectures and software pieces and the number of things that allow one to, the equivalent of the robot arm to build a robot arm. All the components are there, but getting the robot installed into a manufacturing environment and doing things that can be measured, that parallel for AI is still not quite there.
I'm all in on AI assistance, which is a very broad category. I don't care how I interface with it, but having the segment that already exists with the Home Assistant and Siri and Alexa, having a evolution of that and then applying it across more spaces to where, I mean, this comparison has been made a lot, but the Microsoft Office Clippy who pops up in the middle of your Word document and gives you help with, hey, are you looking for so-and-so thing? So some variation where I'm actually interacting with like some variation of Siri in a bunch of different ways that I haven't thought about yet. That, to me, that is the segment to be betting on, because we already know that it's going to work. And my kids are already used to asking each device in sequence what the world's largest estuary is. Like they're already there. They know what it is. My 3-year-old knows how to ask for music to get played. They don't know the term AI. They don't give a crap about the term AI, but it just does the thing that they need it to do.
Yeah.
And it's a very straight line from, I don't know, man, shoot, it was 6 years ago. I'm like, I would love to have voice control for my music in my house. What are my options for that? And there's so much untapped potential, both for just making that number one, work better. Number two, make it more affordable. Number three, give me more options. Number four, maybe a version of it that's not just like blatantly built on collecting my personal data and selling ads off of it.
Yeah, the yin and the yang. So you've explained the commercial version of AI as an assistant. There are also a bunch of industrial versions,
Yeah.
and sort of industry across sectors. There are a bunch of versions of AI, and we'll talk about this when we talk about companies that are doing interesting and innovative things. But I think there are autonomous systems generally, um, are beneficiaries of AI, computer vision specifically. But I think our military is certainly using AI, computer vision, a number of applications. So I think there's the commercial side.
Well, yeah, I'm big on computer vision too, but it's defined, right? Like we know what computer vision is now. It's a matter of making it better, faster, cheaper, stronger, and finding a few new application areas for it, or new places we can stick a camera and have it interpret things.
Yeah, I think there is still room for innovation. There is still room
Oh
for
yeah,
innovation in computer vision on the edge. And I was reading today about a company based in Brussels, but the founders from Italy. It's called Accelera or something like that. But they're developing chips that you can train the neural networks, which are the algorithms behind computer vision. You can train those on the chip, and the processing speed is much higher than what exists today. So there's the cloud-based application where everything's sort of the data centers that have servers, and you train, and there's all this compute at your disposal. But then in the applied arena, that doesn't work necessarily because of latency. You need to make decisions faster. You need your drone to do things based on what it sees in real time or near real time. So you have to have as much of that compute on the device as you can. And there's still some bottlenecks with that
let's
people are working on now.
let's do a computer vision episode dedicated. Maybe a whole week of computer vision.
Sure.
You said something a minute ago that jumped out at me. You're talking about the next $1 billion company, $1 billion idea, whatever, around AI. And I'm looking at the history of robotics. Did anybody ever build the $1 billion robot idea?
No, but there are $1 billion services. In most companies, there are $1 billion services around robotics.
I think
So,
there are $1 billion robotics companies,
oh, for
depending on how
sure.
broad you're taking that definition.
ABB. Now ABB also has other division. That's the thing about a company like that. They started with other things. They came into robotics. A big part of their growth is inorganic, with via merger and acquisition. There are a lot of stuff, but like KUKA, probably, maybe. I would bet Kawasaki.
So
Um,
Kawasaki is going to be like ABB, where it's hard to separate out. KUKA doesn't have a bunch of other divisions, and they have a $3 billion market cap. So there are $1 billion robotics companies.
yeah,
But I think the thing that's fascinating here is you're talking about $1 billion idea for AI or applied AI. The idea of the robot wasn't what got to a $3 billion market cap.
the robot.
It was robot as widget.
Yeah,
So KUKA, ABB, Yaskawa Motoman, Kawasaki, Denso, all of these guys, they're the way that they got to what they look like today as robot companies was not take this idea of a robot. It was take this idea of a powerful industrial multinational corporation, right? And like it could have been widgets, it could have been whatever. And it's almost like the idea of robot was so commoditized that that's the way it got to
You
be.
you just explained it. Breaking news. I think we're first to this spot. You just explained, and I say that very facetiously. You just explained the opportunities that still exist in AI is the widgetization of AI. It's a
Man, it's
concept.
depressing. Maybe
What's that?
that might be depressing. I'm not sure. I'm gonna have to think about it.
No, it is there. It's a loosely held amalgam of tools and software and testbed applications and proofs of concept. But and this is my point that I have stuck my flag in the ground on for 5 years. It is really hard to scale or make a widget out of applied data science. The model for success in AI is a service company. And how do you, there needs to be a tool to scale data science as a service, not necessarily, the widgetization of AI is recommendation engines or computer vision, those types of applications. But unlike the robot arm, it's not something there are intricacies about the math behind AI that are very important distinctions between widgetization of a robotic arm and widgetization of an AI algorithm. The AI algorithm is much more a unique engineered solution.
Can we talk about end effectors for a second?
Love it. Shunk.
Yeah. So, you know, an end effect. All concepts that we address, I will. I'm not going to dumb them down, but I will introduce all concepts that are jargony or in any way esoteric. So, there are a bunch of different words for this thing, but from the end of a robotic arm, generally speaking, an industrial robot arm is sold by itself to a distributor or a sales company, or an integrator, and those companies are then selling the robot arm plus what's called end of arm tooling or end effectors or manipulators or grippers to some sort of application. So if I need to pick up a bucket and move it from here to there, I need an arm to carry a certain amount of payload, and I need a thing to grip the bucket, right? And so that thing to grip the bucket is not generally made by the company that makes the arm that covers payload and speed and these sorts of things. There's a lot of specialization down that supply chain. We'll talk about specialization more later this week, but that everything I say about the genericization and commoditization of robots, none of it applies to end effectors and manipulators, because every single time a robot has to interact with a thing that is being worked on, it's always a custom one-off. So if you think about what to give an illustration of this, one of the examples of the most widely used robotic arm, there's a couple, they're all in automotive manufacturing and assembly or similar applications. One of them would be roof spot welding. So this is literally just the roof panel of a car being picked up by one robot and then welded into place by several other robots. The welder that's on the end of the weld robot and the suction cup gripper that's on the end of the body panel handling robots, all of the action, if you will, about what's interesting about how to make that work comes from how do I get like the perfect suction and the perfect welder and minimize the amount of energy use. And then it's into things like we're doing this at a very, very, very high rate of speed. So how do I get all this stuff super efficient? And all of it is dialed in. And the fact that I can't name, if that's the number one kind of use case for robotics and industry, I can't name the number 9. Like I can't do it, because as I go down the list, things become so spread out so fast that you can't say, oh well, here's the ninth or 10th biggest application for robots, because once you get past the first couple of big few, you're into near universal customization. And the thing that's fascinating is that almost all that customization is coming from what's called the wrist of the robot. So basically before you get to the hand, to the hand. So building robot hand is it's I guess it's the last bastion of industrial robotics, where somebody like George Devol would go and say, hey, I have application engineering that I want to do, and I always want a new problem every day, and I'm thinking in terms of how do I best fix this, how do I manipulate that, how do I move this other thing, how do I interact. And all that stuff is designed based on, you guessed it, a combination of mechanical skill, electrical skill, and programming skill. And that cross section that had existed 100+ years ago that got us to robots absolutely still exists. It's just not in the arm. It's all in the hand now.
So I don't know if you intentionally did, but you perfectly explained the point that I was sloppily making about
About
AI.
AI. Yeah. All of it. It's all in the
Same
hand.
thing. Same thing. And people there that's the area for opportunity and for improvement in terms of scaling AI. A lot of people can and have made the Unimate. The
Yeah.
Unimate you can send out globally, but for the Unimate to be a benefit for an efficiency gain, an improvement gain in the production of something, somebody has to make it specialized for the application that it's being used. And that is the exact, to a T, the exact same parallel with AI today. That very, 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 very few people, I haven't met really anybody, appreciates.
I mean, it's much easier to grasp when you're talking about a mechanical interaction between a roof panel and a robot arm. As you abstract that and make it conceptual for AI, even if you're a computer science expert or a DevOps expert, it gets very difficult to understand which of these things is the AI, which of these things is the tooling, which of these things is configuration,
But
which
go to your and it's such a good point. I want to highlight it over and over and over. Go to your specialization, which we will talk about later in the week. But your spot welding and roof handling, material handling, robot working in unison together. It's not even as simple as, let's say, Shunk or whoever's making the end effectors for those robots. You don't make the same one for GM that you make for Toyota and that you make for Ford and that you would make for General Mills, or as you start going across industries, even the same use cases are going to have different end effectors. They're going to be custom to they need to be modified and built and trained for the application that they're being used for. So I think that is such an important analogy for understanding AI, is that Unimate, we have Unimate in AI today. We have a lot of flavors, mostly complete robotic arm equivalent in AI.
right.
What we don't have at all, unless a company is progressive, Fang does, because they've got an army. Tesla does, Microsoft does, Amazon does. The really progressive companies that have scooped up all the machine learning engineers and all the AI engineers are building this internally, but even they can't scale it because it's uniquely engineered solution for every end user. And so for AI to see the widespread adoption that robotics arms have seen, you and I both know integrators galore. There are a million of them. People, gentlemen who spent their career as manufacturing or robotics engineers for a company, leave and start their own integration firm, and now they're building hundreds of robots a year for. I've seen it here in Kentucky with Toyota. There are other examples that you've seen as well. That's what has to happen for AI. And here's the challenge for AI. This is why no one should be worried. There aren't enough people with subject matter expertise to do that. And this is what I talked about. I think it was last week when I talked about the gulf in awareness of how things work in the 80s, because people were closer to the tech. They understood the technology more. There are fewer and fewer folks with subject matter expertise on how to make AI and machine learning work today. So
I'm
a lot
I'm
there.
I'm concerned. Yeah, concerned is not the right word. It gives me a lot of thought, or a lot to think about when I consider how few people, like I've talked about this idea of proficiency. So it's basically you don't have to know it all, but you are able to work quickly and pick up new material in a particular domain. So, you and I both have manufacturing and automation basic proficiency. We each have advanced proficiency in other more specialized areas. I think it's interesting to think about how few people have proficiency or above in not even AI, but in even just in machine learning or in data science, and also in robotics, or if make that broader. So even if you take the
Industrial systems generally.
yeah, industrial systems plus machine learning or data science, that overlap is really small. I mean, we're talking about, you know, a, less than 10,000 people, right? And like it's just
That
not
that
a
feels
large number of people.
that feels high. 10,000 feels high.
China has something to say about that.
Well, so I sent you
Yeah.
another discussion for another day. But yeah, there are. You're right. This is what when we talk about competency crises in terms of policy, we need a ton more people that understand how to push data around a network, how to make decisions, how to collect and store data about industrial systems, and how to make decisions for these industrial systems, how to use them based on data. I think we need a bunch. There's a skills gap, a subject matter expertise gap there that we is a bit of a crisis.
I think that I think a lot of time and energy is spent on worrying about the high end. So who are the AI? I can't keep being about AI, but who are the data science experts that also have automation expertise? And I think that the bar when you talk about experts
Andrew
is
Mang.
right, but it's you. The target of who we need more of can't be we have to have more experts. Like, yeah, it
Yeah.
would be great to have more
Right.
experts, but what we're really missing is, they're not there when you position it as experts, right, and pick out a couple of individual, superhero type people that have that level of expertise, that creates an invisible barrier to other people feeling like they can never get there.
How do community colleges crank out people for these types of with a level of proficiency for the over
I mean, I don't care where they're coming from. I think it's a matter of having people that are, more or less competent at grasping mechanical and computer science concepts entering industrial spaces. And I don't mean manufacturing by that. I mean manufacturing and, power generation and grid management and utilities, anything that's not, consumer products related or consumer goods related, any of those sort of business to business only types of areas, and understanding that, you can go work at those places, and industry with narrow or sort with like these somewhat specific and esoteric concepts around industrial proficiency, that is a thing that you can do if you're an engineer. It's a thing you can do if you're an English major. It's a thing you can do if you're, writing code on the side. It's a thing you can do if you just like to draw. There are a million and one paths there. And I think the discourse tends to be really, really focused on cranking out engineers. One step back from that is, well, let's crank out STEM grads. Okay, fine. Let's take two steps back from that. Let's crank out STEAM grads and include arts in there. Oh, and then let's take one step back and we'll include, you know, vocational schools as well as 4-year degrees. I think all of that stuff is great, but the reason for this widening and widening and widening and widening is that anybody can enter the space with any skill set. If you become an industrial marketer, like, you can trash marketing. Like, we can separately trash the craft of
crucial. It's
marketing,
crucially important.
but being able to have talent of all kinds enter industrial spaces is a big missed opportunity, which I'm like hugely biased towards, because I don't come from an engineering background. I've never been a practitioner in engineering, but when I'm in engineering circles versus, non-engineering circles, all the non-engineering circle people are like, well, all this stuff, and that's technical in nature, and I'm like, I don't know any of this stuff. I just draw boxes with arrows between them, and it turns out that mostly that's enough, depending on what exactly you're trying to do. And I'd like to apologize to all of my actual engineer friends, who I would also point out need me so that
Yeah.
they can write a coherent sentence
Yeah.
with a subject and a verb.
Well, I think I don't know. You brought some. You were on fire today, by the way.
I just
Really.
like robots. I love what I love about the robots is the breadth of, you came in wanting to talk about the history of robots, but it's the history of robots is a history of industrial progress and a history of, business progress and economic progress and social progress. And it captures all these different things, and it does it with a really heavy dose of, public imagination. And I think that that is a perspective that gets lost if you're just like, I want to go, I want to go build a robot to fulfill factory orders at the Amazon fulfillment center. It's like, it doesn't have to be like that.
Well, I think what interests me. Obviously, we share an interest for robotics and data. All that we've made that point. But what interests me in the history of robotics is, the notion that the past is prologue is very much relevant in this instance. Is there the Unimate, again, George DeVole, Louisville, Kentucky. Um, don't crap on flyover states. The past is prologue. All of the symmetries between everything culturally and all of the hand wringing and pearl clutching around robotics then still applies today to choose your technology. And I think it's just all of the parallels between the origins of the robot arm, the person who made it successful. I think those parallels today are very much intact and fascinating to me. And the whole thing. I want to we'll leave you my last thought. 1961, GM paid $18,000 for the first Unimate. It took 65,000 to make that. Unimation, the company, the company that produced the Unimate robot, didn't turn a profit for 19 years.
Oh my God.
19 years. How many VC funds in today would tolerate 19 years with no return?
That's it. We're done. See you next time, Terry.
Have a good one, man.